There's this invisible engine that powers pretty much your entire modern life. I mean, from the phone you're holding to the car you drive, from the data centers that run the cloud to the rockets that go to space, it all runs on one thing, the lithium-ion battery. So today, we're going to deconstruct this tiny powerhouse and really understand how it completely reshaped our world. So let's get into it. 158 or 300? Now, this number might not look like much on its own, but trust me, it's the reason the 21st century looks the way it does. It's a measure of energy density. Basically, how much power you can cram into a really tiny space. And over the last few decades, we got insanely good at packing it in. So what does that number actually mean for you and me? Well, it means our entire world became portable. It's the reason a supercomputer can literally fit in your pocket. It's why your car can go for hundreds of miles with zero emissions. And it's why you can stay connected to pretty much anyone, anywhere on the planet. This one metric, it unlocked our whole mobile, electrified reality. Okay, so to really get our heads around this, we're going to go on a little journey. First, we'll look at why this battery became king. Then we'll dissect its core anatomy. We'll watch how it gets forged in fire and foil, witness its very first breath, and finally, we'll follow its entire life story, from birth to whatever comes next. All right, so why this technology? I mean, what makes the lithium-ion battery so special? Well, it's this killer combination of having a ton of energy in a small package, being able to be reused over and over, and get this, it barely loses its charge when it's just sitting around. So what's actually happening inside one of these things? We're not burning any fuel here. A lithium-ion battery, it's more like a tiny, perfectly controlled chemical dance. It's just the elegant, reversible movement of these little things called lithium ions from one side to the other, and then back again. That simple back and forth, that's where all this power comes from. And because this design is so brilliant, it has led to, well, total global dominance. It's in the phone in your hand, it's in the electric vehicles on the street, it's in those massive batteries that store wind and solar power. It's even in the hardware that runs AI and sends us to space. It is, and this is no exaggeration, everywhere. So how does this dance of ions actually work? To really understand it, you've got to meet the 4 key players that are inside every single battery cell. First up, you've got the cathode. That's the positive side, and the anode, which is the negative side. Now, shuttling between them is the electrolyte, which you can think of as a superhighway just for lithium ions. And finally, you have the separator, a physical barrier that acts like a bouncer at a club, letting the right ions through, but stopping the two sides from touching and causing a short circuit. Okay, the core idea here is actually surprisingly simple. When you plug in your phone to charge it, all you're doing is using electricity to push the lithium ions from the cathode over to the anode. That's it. Then, when you unplug it and start using it, those ions naturally want to flow back to the cathode. That flow, that is the electricity that powers your world. It's really just a physical game of back and forth. Let's zoom in on the two ends of this ion highway. The cathode, the positive side, is usually a mix of metals like nickel, cobalt, and manganese, and it's all coated onto a super thin sheet of aluminum foil. On the other side, the anode, the negative side, is typically a layer of graphite that's coated onto a thin sheet of copper foil. These specific materials aren't random, of course. They're chosen because they are the perfect hosts for all those lithium ions. So how do you actually make one of these things? Well, it's not exactly a simple recipe you can follow at home. Manufacturing a battery cell is this incredibly precise, multi-billion-dollar process that happens at a scale that's just hard to imagine, all inside these giant gigafactories. Let's just take a look at the cathode. First, you mix these key metals with lithium. Then, you cook that mixture at over 700 degrees Celsius to create the active material. This powder then gets mixed into a super precise paint-like slurry, which is then coated onto aluminum foil with unbelievable precision. And finally, these giant heavy rollers press that foil down to the absolute perfect thickness and density. And just to give you a sense of the insane level of control that's needed here, this whole process happens in these ultra-dry rooms. We're talking less than 1% humidity. That is way, way drier than any desert on Earth. And why? Because even one single microscopic water molecule can basically poison the chemistry and completely ruin the battery. The target they're shooting for with moisture contamination is less than 20 parts per million. To put that in perspective for you, that's like trying to find just 20 specific drops of water in an entire Olympic-sized swimming pool. It's an almost unimaginable level of purity, and it is absolutely essential. So after a cell is assembled and sealed, it's not really a battery yet. It still has to take its very first breath. This is what's called the formation stage, and it's where the single most important and completely invisible part of the battery gets created. It's called the Solid Electrolyte Interphase, or just SEI for short. And this part is fascinating. It's this microscopic layer that actually forms on the anode the very first time you charge the battery. You see, you don't build this part, the battery grows it all by itself. And its job is, well, it's absolutely critical. This SEI layer, it only forms once, but it spends the rest of the battery's life acting as this perfect one-way gate. It lets the lithium ions pass through, no problem, but it blocks electrons and stops the electrolyte from just continuously breaking down. Honestly, without a stable SEI layer, a battery would die in just a handful of cycles. It is the key to safety and a long life. But nothing lasts forever. So in our last section here, let's take a look at a battery's entire journey. Why it fades over time, what's coming down the pipeline next, and where it goes when its first life is finally over. Ever wonder why your phone battery just doesn't hold a charge like it used to after a couple of years? Well, there are basically three main culprits. That really helpful SEI layer can actually grow a little too thick, which slows everything down. If you fast charge too often, pure lithium can get kind of stuck on the anode. And the cathode itself can develop these tiny little micro cracks from all the use. Each one of these things traps a tiny bit of lithium forever, and that's why your battery's capacity slowly fades. So what's the next big leap? Everyone is talking about the solid-state battery. The key difference is replacing that liquid electrolyte with a solid material, something like a ceramic or a polymer. And the goal? To pack in even more energy and make them even safer. While today's batteries are this proven low-cost technology, they're kind of getting close to their physical limits. The biggest hurdle for solid state right now is just figuring out how to manufacture it at the massive scale we see today. But here's the really cool part. A battery's story doesn't just end when it's dead. When a big EV battery can no longer handle the stress of driving, it can have a whole second life. These millions of batteries are now being linked together to create these huge energy storage systems, helping to balance our power grid and store massive amounts of solar and wind power. It's a really brilliant path to a more sustainable future. So there you have it. We've gone from a simple number to this global manufacturing marvel that literally powers our entire civilization. I mean, we have truly mastered the art of the lithium-ion battery. So the only question left to ask is, what incredible new challenge will the next generation of power unlock for all of us? Thanks for tuning in.